Hello everyone, I welcome you all in the course Introduction to Sequence Stratigraphy. We are now discussing about the different sequence elements, and we are discussing on the first type of elements, that is the surfaces in sequence stratigraphy. And within that part, in the previous class, we have discussed about a broad overview on different types of surfaces in sequence stratigraphy. So, to continue with that, today we will discuss about one particular type of surface which is very important in sequence stratigraphic approach, and that surface is unconformity. So, today's class is about unconformity in sequence stratigraphy. So, before we start this discussion, I will just would like to recall the overall list of surfaces which are commonly associated with base level fall. So, this we have discussed earlier in our class on sequence elements, where based on these two basic curves we have tried to find out these four major events, and based on those four major events we have tried to identify the major sequence stratigraphic surfaces and the different system strats. So, there we categorized three different types of surfaces. One, those surfaces which are associated with base level fall. There are some surfaces which are associated with base level rise, and there are some minor surfaces which occur within the system strat, commonly called as the within trained facies contacts. So, today we are starting our discussion. This will be a series of discussions in successive classes, and today we are starting with those surfaces which are associated with base level fall, where we get the first name which is associated with this particular type of category of surface is the unconformity. The second surface which is associated with base level fall is correlative conformity. Correlative conformity. The third surface that is associated with base level fall is basal surface of force regression, BSFR. And the fourth surface which is associated with base level fall is the regressive surface of marine erosion, RSME. So, these four categories or these four different types of surfaces, major surfaces, form within a sequence during the phase of base level fall. Definitely we can define or we can find out other surfaces which are associated with base level rise, for example, maximum flooding surface, for example, the maximum regressive surface, ravinement surface, etc. So, today we are starting our discussion on the sequence stratigraphic surfaces on this particular category, starting with this particular category, those surfaces associated with base level fall, and we will gradually cover up these different surfaces. So, our topic today is unconformity, which is one of the major surface associated with base level fall that we commonly found in sequence model. So, unconformity is a very general term. Those people who are associated with earth science, they get acquainted with this term, get introduced to this term at the very early stage of their study, because unconformity is a very general term used for any strata, any succession where we get substantial break or gap in the geological record. So, not necessarily it should be a sedimentary unit only, there can be igneous metamorphic rock bodies also associated with that. So, whenever there is a substantial break or gap in the geological record, which can be associated with some amount of gap in the process, sometimes it can be a sedimentary process. So, there should be significant hiatus, which may be or may not be associated with some amount of erosion. Commonly unconformities are associated with erosion, but there are instances, we will see that in our discussion, during our discussion on sequence stratigraphy, that there can be simple hiatus also, which can lead to an unconformity. But in general, when we discuss about unconformity, irrespective of the concept of sequence stratigraphy, in general unconformity is a combination of these two factors, hiatus in the process as well as some erosion. So, based on the nature of these different types of unconformity, different type of hiatus and erosion and the type of occurrences of the rock bodies, we can find out different types of unconformity. So, whenever we get an unconformity in a rock succession, in a stratigraphic succession, it normally implies that there is some sort of erosion, and normally when erosion will start, there is some uplift. So, very commonly unconformity correlates to some amount of uplift, and that is associated with some erosion with loss of previously formed rock records. So, the relationship between rock strata in the contact characterized by lack of continuity in the deposition and that corresponding to the period of non-deposition, weathering or erosion. All these together can form unconformity. So, all these features, all these events will occur before the deposition of the younger beds or younger strata, and that will demarcate a surface of gap, surface of hiatus represented by either bypass or no processes going on, hiatus, or a surface of erosion. So, unconformity can be of different types depending on what are the different types of rock type associated with that particular surface of gap, surface of hiatus. So, the first type is called as disconformity. Commonly, this is a combination of hiatus and erosion together, where we commonly get an unconformity where sedimentary rock strata, bedding planes above and below the break, they are essentially parallel to each other, indicating a significant interruption in the underlying sequence or sedimentary rocks, very commonly by erosion, usually marked by a visible and irregular or uneven erosional surface of appreciable relief. So, how a disconformity will look like if I want to draw? So, there will be some parallel lines, and these parallel lines are separated by an erosional surface like this, which are underlain by again some parallel sedimentary rock bodies. So, these are sedimentary rocks, these are also sedimentary rocks which are having similar or near parallel bedding characteristics, and this is the erosional surface which is marked as unconformity, particularly disconformity. So, very commonly disconformity can be observed in sedimentary basins within sedimentary successions where the overlying and underlying units are both sedimentary rocks. Now, we can have a second type of unconformity which is called as a paraconformity, where dominantly we get some hiatus which may be associated with some erosion. Erosion is commonly not that prominent as in case of disconformity. So, this kind of unconformity is commonly defined as an obscure or uncertain unconformity, because here the surface is not demarcated by very dominant erosional process. So, when the bedding surfaces, bedding planes, they are parallel to each other in the underlying and overlying part, and they are separated by one surface which is non-erosive in nature. So, apparently it will appear almost parallel to the original surfaces, original bedding planes, and in such cases it becomes very difficult to identify. So, it is an obscure or uncertain unconformity in which commonly we do not get any erosional surface, and the beds above and below this particular surface, which is a kind of surface of break, are parallel to each other. So, how this kind of unconformity look like, this paraconformity? So, the underlying beds are parallel beds like this, which are definitely the sedimentary beds. Now, on that we have a surface, that particular surface is the surface of hiatus. So, this is the unconformity surface, and on that again we are getting sedimentary beds which are parallel to each other, and they are parallel to the underlying unit. So, again we are getting sedimentary rocks over here or sediments over here. So, in such cases this particular surface is called as a paraconformity, and often it becomes very difficult to identify this surface except there is some major edge difference between this underlying and the overlying units. That edge difference can be analyzed through some edge dating method or maybe through association of some fossils, characteristic fossils demarcating completely different age. The third type of unconformity is called as angular unconformity, which is the most common type of unconformity and which can be very easily identified in the rock record. So, it is commonly associated with hiatus, along with that erosion, and commonly associated with some tilt before that phase of erosion or hiatus. So, this kind of unconformity commonly occurs between two groups of rocks, and commonly the overlying units are sedimentary rocks, whereas the older underlying rocks, they can be sedimentary rock or they can be other rocks which have gone through some amount of deformation, and that deformation may have changed the orientation of the rock, may have changed the inclination of the rock. So, this kind of unconformity between two groups of rocks whose bedding planes are not parallel or in which the older underlying rocks dip at a different angle, commonly more steeper than the younger overlying strata which are commonly parallel to the unconformity surface, mostly horizontal. So, if I want to draw an angular unconformity, so if unconformity surface is like this, then the underlying units are dipping something like this. There can be any possibilities, and the overlying units are parallel to the unconformity surface. So, very commonly these are the sedimentary rock body, this is the unconformity surface which is an angular unconformity, and these are the underlying units which can be any rock body, maybe a sedimentary rock body which has gone through some deformation, then erosion and a gap along this particular surface, and then these new sediments are deposited above that unconformity surface. So, these are called as angular unconformity, very commonly identified, very easily this can be identified in the rock record. The fourth one is again a very common one which we call as non-conformity. So, in case of non-conformity, it is commonly the sedimentary rocks occurring above the basement rock, and in most of the cases the basement rock is either a igneous rock or it is a metamorphic rock. So, these are unconformity which is developed between sedimentary rocks which are the overlying and older igneous or metamorphic rocks that have been exposed to erosion before the overlying sediments covered them. In most of the stratigraphic succession, whenever the first sedimentary succession starts above the basement rock, we get a non-conformity. So, a non-conformity will be look like this. If this is the unconformity surface, then below this we have some igneous rock body, maybe some gneiss, maybe some metamorphic rocks like schist, maybe a complex like Chotanagpur gneissic complex, maybe some complex rock bodies available over here which have gone through several phases of deformations. So, all complexities are present over here, and then this has gone through some amount of erosion as it was exposed for long time, long geological time, and then on this unconformity surface sedimentary rocks are deposited like this. So, this particular surface is the unconformity surface separating these older igneous or metamorphic rock bodies which are the basement rocks, and these are the cover sediments which are overlying the unconformity surface. So, these are non-conformity. Apart from these four major types of unconformity, we can also get another type of hiatus surface which is a kind of relatively less prominent unconformity surface. So, this kind of surfaces are called as diastem. So, what is a diastem? Diastem is commonly associated with very short phase of hiatus which may be or may not be associated with some amount of erosion. So, this can be identified as a small scale representation of a paraconformity, where within the sedimentary succession we get a relatively short phase of interruption in the sedimentation, which involves only a brief interval of time during which little or no erosion before deposition is resumed. So, in such cases a depositional break of lesser magnitude, when I am talking about lesser magnitude in terms of its lateral correlation, spatial distribution, it should be very limited within a particular phase or particular area of the depositional basin, and within that phase we can identify a very minor paraconformity which can be identified as a diastem. So, diastem is a small scale unconformity, small scale paraconformity, which indicates short phase of hiatus. When we talk about the sequence stratigraphy concept, because whatever we have discussed so far about unconformity, they are the common terminologies, they are the common types of unconformity, and these are commonly we get used to all these terms, we learn about all these terms at the very early stage of our study in earth science. But then comes the point that what is the use of this concept of unconformity in sequence stratigraphy. So, there in sequence stratigraphy, we commonly use a term called as subaerial unconformity. It is not a simple unconformity, it is a subaerial unconformity, that is the term used. So, a subaerial unconformity, it is definitely an unconformity. So, this is a surface of erosion or non-deposition, and it is commonly created during the base level fall, during the phase of base level fall by subaerial processes. So, some portion of the marginal part of the basin, it is getting exposed due to base level fall, due to sea level fall, and due to that exposure, the fluvial systems which are associated with that basin, they tries to adjust themselves, they tries to adjust their graded profile, equilibrium profile, and in order to do that, fluvial systems, they start incising, they starts eroding. So, this kind of fluvial incision, this kind of erosions associated with wind in those exposed areas can also be associated with sediment bypass and sometimes may get associated with some soil forming process like pedogenesis. So, all this together during this base level fall phase can produce a surface which represents a gap in sedimentation, a gap in sediment supply. So, that is a bypass or simple erosion, and we identify that as a subaerial unconformity in sequence stratigraphy. So, it generally extends basinward during the force regression of the shoreline and reaches its maximum extent at the end of the force regression. So, when the sea level, base level starts falling, at that time gradually we get the surface of erosion forming, and that surface of erosion will extend in both direction as the base level goes on falling, and it extends in both the directions. So, owing to their timing and mode of formation, subaerial unconformities correspond to the largest stratigraphic hiatuses in the sedimentary rock record, and they commonly separate the strata which are genetically unrelated. So, this we have discussed in case of our discussion on types of sequence, depositional sequence, genetic stratigraphic sequence. So, whenever we get an unconformity, that will lead to sudden change in the depositional regime. The underlying strata, underlying facies may be something associated with the marine system, and then there is a fall in base level, and that fall in base level will lead to significant amount of bypass and erosion, and then when that phase is over, then we get maybe a sea level rise, and that sea level rise will lead to or bring in some other type of sedimentary facies, other type of depositional condition in that particular area. So, across that unconformity surface, what we will get? One type of facies in the lower part of the unconformity, and completely different type of facies formed in completely different sedimentary environment overlying the unconformity surface. So, they commonly mark abrupt basinward shift of the facies. That is a characteristic of unconformity, that is a characteristic of identifying unconformity. So, force regressions, they commonly require fluvial systems to adjust to new graded profile system, new water level, and in order to do that, in order to come to this new graded profile, so this downstream reaches of the fluvial system, they have to go through severe erosion. If this was the base level and from there the base level is coming down, so definitely a river system which was coming from this side and was in complete equilibrium with that base level position, is suddenly it has to adjust itself, it has to come down to that new level through that much of erosion. So, that erosion, that adjustment of the fluvial system leads to sediment bypass or channel incision. When this channel is incising, so if this is the channel part and this is going through erosion, so it is deepening gradually. So, water level within that channel, it is also gradually going down along with the base level fall. So, what is happening in the interflow areas, in the overbank areas? So, those areas are now completely devoid of any sediment supply because they are not under water cover. They are completely exposed now. So, they are going through sediment starvation, and when sediment supply is not there, when no water is working on them, they are subaerially exposed. So, definitely they will go through some amount of soil development where vegetation will also form. So, within these interflow areas, within the overbank areas, that gap in the sedimentation will be represented by formation of soil. So, that soil formation, the top of the soil formation will indicate that end of this regressive phase. The subaerial unconformity can be traced at the top of paleosoil horizons in sedimentary successions, at the top of the paleosoil horizons that are correlative to the unconformities generated in the channel sub-environment. So, within the same channel overbank area, we can get two different surfaces which are correlatable to each other. As the channel is gradually going down, we will get a final surface of erosion which will demarcate the final unconformity surface. And along with that, during that phase of erosion within the channel can be correlated to another surface in the overbank area, in the interflow area, which demarcates the formation of soil, the end of soil formation phase. So, unconformity can be represented in different ways through different features in sedimentary successions. The underlying fluvial to salomarine strata, that can be either normal regressive condition, normal regressive strata, or it can be forced regressive strata. Particularly when we are looking into the marginal marine part, where part of the early phase of forced regressive strata can get preserved. So, we have to understand one thing over here. So, when this base level is falling, what is happening is the fluvial systems, they are gradually going down, they are gradually cutting down, incising down, and that incising process is confined within the channel only. So, when the deposition started somewhere here, from the deposition during the forced regression started in the marginal marine part, and after that when the fluvial system is occupying that area, it is trying to incising through that area, that incision process is confined within the channels only. Beyond the channels, the overbanks of the channels, there the earlier deposits are preserved, they are not eroded. Only the top part of that deposition is going through some soil forming process and getting modified. When we look into this unconformity, we can get different types of packages. Somewhere it can be the normal regressive package which was formed in the last HST phase, because when this erosion is starting, it is cutting down the earlier HST, which is a very normal case. Or sometime we can get the forced regressive package within the area of forced regression, we can get that package preserved, because when the channel is incising, the overbank areas of the channel, they are not eroding, they are just bypassing the system. So, those packages formed in the early phase of forced regression, particularly in the marginal marine area, they get preserved. Now, on top of the unconformity, that is the strata or packages which will overlay the fluvial deposits, they can vary. So, they can be normal regressive or transgressive packages, because after this unconformity, when this falling stage is over, base level will start rising, and that base level rise will lead to kind of aggradation, and that aggradation may be associated with retrogradation. So, that retrogradation or aggradation will start from the end point up to which the unconformity has reached during the late phase of or end of the forced regression. And from there, now the system, the depositional system will start rising up, and it will try to cover up it will try to move backward towards the shoreward, towards the landward direction, and depending on how much that backward movement is occurring during this phase of LST or in the next phase of TST, in different parts of the unconformity, in the overlying area of the unconformity, we can get either the normal regressive package formed during the low stand, or we can get a retrogradational package formed during the next phase of transgression. So, that will depend on what is the landscape gradient, what is the degree of development of low stand regressive strata, how much backstepping is occurring, how much low stand onlap is occurring. So, this will vary from area to area. So, commonly if we want to identify subaerial unconformity, it may overlie any type of depositional system. So, as I have told you earlier, so if this is the unconformity developed because of this fluvial incision, so below that we can get either the HST, which is ideally required, or maybe when we go into the deeper part, in this part we can get the FSST deposits which are formed in the marginal marine part. So, this may be the end point of the unconformity during the force regressive phase, and after that next low stand is starting with rise of the base level. So, during that time, as the base level is rising, so the sediments will try to cover up like this. So, it will be overlain by the non-marine deposits, mostly the fluvial systems, but these fluvial systems will try to onlap on this unconformity surface. So, overlying non-marine deposits, they are one of the characteristic feature for recognition of a subaerial unconformity, because when this base level fall is going on, the channels, they are incising. Initially the channel was here, the water level was here, now the channel is going down and the water level is coming down to here. Then the channel is further cutting down and it is coming over here. So, the new water level is here. So, this surface is the erosional surface, and this surface is forming during the base level fall, during the force regression. Now, this surface is the unconformity. After that, this base level rise has started, and as the base level rise has started, water level is rising up now, and that will lead to deposition of sediments over here. What kind of sediments? Definitely the fluvial sediments, because this is happening within the channel. So, always unconformity, particularly when we are talking about the subaerial unconformity, it should have an overlying non-marine deposit. This is the identifying criteria. This is a very recognizing criteria for subaerial unconformity. So, the underlying package can be anything. It can start from shore facies, it can start from shore to the underlying deltaic facies, or maybe even the fluvial facies. So, below the unconformity we can get all these type of packages formed during the HST or maybe during the FSST. But in the overlying area of the unconformity, it should be represented by the non-marine fluvial deposits. Since the unconformity subaerial erosions, they are associated with removal of the sediments, commonly we do not expect formation of any ichnofacies or ichnofabric characteristic of unconformity. But in some cases, particularly when we are talking about removal of some recent sediments and maybe exposure to some earlier sediments which are relatively fine grained, so they can form local farm grounds. And if those farm grounds go through some amount of exhumation in a semi-cohesive condition, they can form farm ground substrate condition for the formation of some marginal marine ichnoform to develop, particularly those associated with farm ground condition. But these are very rare, very localized. So, apart from these, we do not expect much substrate controlled ichnofacies to form associated with subaerial unconformity. So, what kind of ichnoforms can be expected associated with subaerial unconformity? Number one, non-marine soft grounds ichnoform. For example, those associated with river system, particularly those associated with the soil system formed in the overbank areas. So, the paleosol related ichnofacies like termite ichnus, this is one of the common ichnoform which we can expect associated with unconformity. Second one, we get abrupt shift from marine to overlying non-marine ichnofacies. As I have told you, say this is the unconformity. So, below this unconformity, maybe this is a shore facies is present over here, which is going through erosion. But within this shore facies, which is finally present, finally preserved after the erosional phase, within that we can get marine ichnoforms, marine ichnofacies, which may be overlain by when the fluvial system is onlapping. Within this fluvial system, we can get non-marine ichnoforms, non-marine ichnofacies. So, we get a complete changeover across the surface, a drastic sharp change in terms of ichnofabric from marine to overlying non-marine ichnofabric. And apart from this, within these paleoshoals, since they are often highly vegetated, so we can get some root structures or paleo root structures, traces of roots present within this succession. So, these are some of the ichnofacies or ichnofabrics which can be associated with subaerial unconformity, and when we look into the overall succession along with the geometry of this stratal stacking pattern, arrangement of the strata and identifying the surface, these ichnoforms or ichnofabrics can also be associated for our interpretation. So, the stratigraphic hiatus, which is commonly associated with the subaerial unconformity, it can vary, which is commonly due to the differential fluvial incision at different parts of the basin and the gradual expansion of the subaerial erosion in a basinward direction during the stage of base level fall. If we think of series of stages of base level fall, so initially the fall amount is less or its effect is less, so the extent of the unconformity will be less laterally. As the base level is falling down, it will gradually expand laterally because of the increasing expansion of the fluvial incision, increasing amount of erosion going on in both the direction. So, what we get is gradual expansion in a landward direction towards the upstream direction along with the migration of the fluvial nick points, which is associated with the adjustment of the fluvial graded profile, fluvial equilibrium profile with gradual phases of fall of the base level. So, I can explain this to you with a diagram, which is a very common diagram, very simple diagram. So, maybe this is the fluvial graded profile at say time t1, and with respect to this we have a marine basin and this was the base level. So, this is time t1. Now, from here the base level is falling and it is coming down to level t2 or time t2, and it is coming down to this particular level, gradually falling. So, during this phase of fall, when initially the fall started, the initial erosion was confined over here. So, the major erosion of the river system will be confined in this part and we get this new surface, new equilibrium profile formed. So, initially it was like this and we get a surface like this, which is the earlier surface was this one. I can say this one as K1, this is the nick point, fluvial nick point. So, this is K1 for first phase of fall, first phase of adjustment. Now, as the base level is falling further, it has to adjust, this base level has to adjust, the equilibrium profile has to adjust with this falling base level, and we can get a new nick point formed like this. So, this is the portion now eroded. So, we get this new surface formed, and in that way it will gradually go on, it will gradually move on like this. So, at some point, say when it is reaching to time t2, so this is the final profile at time t2, which indicates the fluvial equilibrium profile or fluvial graded profile. This is the position, this is the type of adjustment, and for this we are getting series of nick points formed gradually, which is migrating back towards the landward side. So, this extent of erosion which started from here with formation of first nick point movement is gradually expanding, and along with that the unconformity surface which is also produced here is also expanding towards landward direction as well as it is moving towards the seaward direction. So, fluvial incision and nick points they show a gradual migration with successive phases of movement of the fluvial graded profile when it is trying to adjust itself with respect to the falling base level condition. So, subaerial unconformities, they can also form during shoreline transgression. Basically, some erosional surfaces, they can also form during shoreline transgression, particularly when the transgression is just starting at the very initial phase of transgression, where extreme wave energy results in coastal erosion. So, in such cases, often it becomes a question mark that there also some erosion is occurring. So, whether we should call this one as an unconformity as well? No, that is not an unconformity, because in such cases the subaerial unconformity is commonly reworked by, or it is commonly represented by, a transgressive ravinement surface which may be caused by wave ravinement or tide ravinement surface. So, this is basically erosion caused during transgression due to increased wave or tidal energy, and where it differs from an unconformity. In this case, commonly the surface is enlapped by transgressive shallow marine deposits and no intervening fluvial or coastal deposits accumulate during shoreline transgression. In case of subaerial unconformity, as we have just discussed, it should be always overlain by a non-marine deposit, commonly the fluvial deposit. In case of transgressive wave ravinement surface or transgressive tide ravinement surface, always we expect some marine sediments, transgressive shallow marine deposits to overlie this surface, which demarcates the difference between these two. So, finally, to conclude with this discussion, we expect the formation of subaerial unconformity within incised valley systems, which may be very easy to identify at the base of coarse grained valley fill deposits, which may directly overlie the fine grained shallow marine strata or maybe some earlier fluvial deposits. So, identifying subaerial unconformity requires the preservation of fluvial strata above the basal unconformity of the incised valley. The subaerial unconformity can also be marked by sharp facies contact in fully fluvial successions, where abrupt shift in the fluvial styles are recorded across the contacts. So, initially it can be meandering system followed by a braided system followed by again a meandering system during the next phase of low stand systems tract. So, that kind of variation can also help us to identify subaerial unconformity. Such contrast in the fluvial styles commonly reflect variation in the fluvial energy level, fluvial energy flux associated with basinward shift of facies. So, when the graded profile is going down, maybe we have a more increased slope of the river system, which may lead to higher energy condition, which may lead to formation of a braided river system. Supply of sediment is also very high, whereas when it is going through some aggradation process, maybe during the next low stand, during that time, due to this aggradation, due to rising of the base level, the slope of deposition is changed, it is gentler now. So, it is a low energy condition, supply of sediments are also quite less. So, it may get changed into maybe a low energy braided river or maybe into a meandering river system. So, that kind of changeover, such contrast in the fluvial styles commonly is associated with increase or decrease in the fluvial energy level, which is controlled by the adjustment of the fluvial graded profile with respect to base level position. So, well drained and mature paleoshoals are one of the key criteria to identify subaerial unconformities, because they can mark the position of subaerial unconformity at their top, as they commonly form during the times of base level fall and during the lowering of the water table in the non-marine portion of the basin. So, subaerial unconformity is one of the most important type of stratigraphic contact. As we have already discussed in our previous class during our discussion on types of sequence, we have seen that the depositional sequence, it is identified, it is demarcated based on the position of successive subaerial unconformities. So, commonly the subaerial unconformities correspond to the most significant break in the rock record, particularly in sequence stratigraphic paradigm, and they separates the sedimentary succession into relatively conformable packages of genetically related strata. Across the unconformity, we can get a completely different package which may not be genetically related, but in between two successive unconformities, we get conformable package of strata which are genetically related, and we commonly identify them as depositional sequence. So, these are most widely adopted sequence boundary in most of the models. These are some of the references that you can go through for further reading. Thank you everyone.